Welcome pre-calcers to day 5 of chapter 8, where we're going to graph sine and cosine functions. So today we're going to talk about amplitude at the beginning. Amplitude, remember, is the height of the graph. So from the center up or the center down, it's the height of the graph. So we're going to look at the fact that our normal graph, y equals sine of x, has an amplitude of 1, because normally there's a 1 in front. Versus if it's y equals 2 sine of x, notice every point is just shifted so that the height is now 2. So that's the amplitude. Still has the same period of 2 pi. Notice the period is where it repeats the pattern. Well, it still increases, decreases, and goes back to that starting point, still within 2 pi. We also can look at the amplitude as a fraction. Maybe the amplitude height decreases. Well, here is our normal blue, y equals cosine of x, amplitude of 1. If we change the amplitude to 1/2, notice the height pretty much decreases by a half. It gets shrunk together. Still has the same period of 2 pi. And let's kind of look at them on Desmos. I think that will be something interesting to look at. So we start here with sine. Starts at 0, 0, goes to 2 pi 0. We have our unit circle points that we now have talked about, the unit circle unraveling. Every point stays the same in the x position, but it just gets shifted up. Instead of pi halves 1, it goes to the point pi halves 2. So what I would do is still have the same 5 points, same 5 x values, because those come from the unit circle, but instead of it being 0, 1, 0, -1, 0 as the corresponding y values, it gets increased by 2. Same thing happens with the cosine function. It has 0 to 2 pi. You have your 5x values as you unravel that unit circle. If the amplitude is 1/2, notice it's the same points, same x values, but the purple is shrunk together. So very cool to see these visuals. That's the amplitude. The period is still the same. It doesn't expand at all. It has the same period. So back to some examples. Let's now graph. Graph the function y equals -2 sine over 1 period. On which interval is the function decreasing? Okay, when I graph, I'm going to make sure to have my xy axes here, however you want to draw it. I do need to label my 5x values. So we have our 0, 0. Maybe I'll go by 2s or 3s will actually work. This will be pi half. So that's 1, 2, 3. 1, 2, 3 will be pi. 1, 2, 3 will be 3 pi over 2. And this will be 2 pi. You definitely could expand this more, maybe put 4 boxes in between. But you do need these 5 labels. Obviously this is 0. And those are our 5 labels. Keep in mind the amplitude is 2. But there's a negative sign. That negative sign just tells us instead of starting my curve up and down, like up here, instead of starting up, then down, since it's negative, it's going to go down, then up. There is no such thing as a negative amplitude, but the direction starts in the negative position. So to graph my points, I know sine of 0 is 0. I can think of that again with my nice xy axes. This is 1. And just start unraveling. Normally, sine of pi halves is 1. But the amplitude is 2. So it starts here. But it's negative. So that means it's going to start on the opposite direction. I'm going to go ahead and label this as -1, -2. I'm just going to skip every one just so we can really see. So this pi halves will now be at -2. Sine of pi is still 0. So that doesn't change with the amplitude at all. We're going to kind of see this pattern. 3 pi over 2 will be +2, and 2 pi is always 0. So this is my curve. Y equals -2 sine of x over 1 period. The period is 2 pi. We're going to figure out where the function is decreasing. Well, decreasing is going to happen from here to here and here to here as you read left to right. So the decreasing intervals you can say is between 0, maybe I'll write it, yeah, this works, pi over 2, and from 3 pi over 2 to 2 pi. Anywhere that's decreasing as you read left to right. You can also write it, I guess we don't consider these if you want to be specific. You also could write it in interval notation. So you can say 0 to pi halves, or you can say 3 pi over 2 to 2 pi. Just getting the idea that it's decreasing. It would not include the point because at that point it's a solid constant point. So please do not put the lines underneath, and do not put brackets. It's going to be just those parentheses. Okay, now these next two examples are very intense. Okay, we're going big picture, and then on day 6 we'll actually clean it up and go a little bit slower. But these are going to be the big mamma jammas. Think about everything we've talked about. Y equals A is the amplitude. Bx minus c gives me either that phase shift or period change, or both. And then I got some information here. Use it as you will. It's kind of nice and laid out for you. So let's just jump in. If at any point you have questions, write them down so you can bring them to class with us. The first example, y equals -2 sine 3x minus 2 pi over 3. We're going to find the amplitude, period, x-intercepts, and intervals where it's increasing this time. Okay, first thing I want to notice is that the amplitude is 2. So I'm going to stretch my graph by 2 in every y direction. It is negative. So that means the direction it's going to go is opposite of a normal sine function. It's going to start decreasing first. I notice I have some information in here. I think to myself, what's the normal period of a sine function? And that's 2 pi. So you put your bx minus c in between the period length of 2 pi and solve for x. That means adding 2 pi over 3 to both sides. Make sure you get your common denominators. This would really be 6 pi over 3 plus 2 pi over 3 is 8 pi. And divide by 3. So 2 pi over 9, 8 pi over 9. This is my new phase shift. Right, this right here gives me my starting. This is my ending. So I'm shifting to the right, 2 pi over 9. And then my period is the length between this. 5 pi over 9 to 2 pi over 9. That distance in between, I guess I'll just write that here. The period would be 5 pi over 9. The distance between my starting and ending value. Let's see, I have amplitude, I have period, I need some x-intercepts. I think those are going to be easier to find once I graph. So I'll just kind of write it here that I will find them. And then I also need to find when it's increasing. So I'll actually move this down. All about organization. and we'll figure out when it's increasing. Okay, let's start by graphing our x, y axes, and we're going to apply all this information to the graph. So here is a basic y and x. Based on my information, I have to start at 2 pi over 9. So maybe I'll start here. Here will be 2 pi over 9. You do need to label all 5 points. Let's see, I have to get to 8 pi over 9. So what if I did every 3? That sounds good. So 1, 2, 3, 1, 2, 3. And my ending is my 8 pi over 9. To find my other points, you have to add the ends, divide by 2. So for example, I have 2 pi over 9 plus 8 pi over 9. I'm going to add those together, 8, 9, 10. So 10 pi over 9. Then you need to divide that in half, right? We're finding the midpoint. So dividing that by 2, you'll see it's 5 pi over 9, and that becomes your middle point here, 5 pi over 9. Add, divide in half, because you're finding the middle part. Do the same thing with 2 pi over 9 plus 5 pi over 9. You get 7 pi over 9. Divide by 2, 7 pi over 18. This last one will be 13 pi over 18. And for me, this gets a little messy. So options here, obviously this is work that you want to keep to make sure you don't make any errors. But I might take all my labels and maybe just put them below. Or you can put them there. It doesn't matter. It's just trying to keep you organized. You do have to have them labeled in some way, shape, or form. Now we're going to look at the fact that it's a sine function. Amplitude is 2. So maybe I'll go, this is -1. Oops, sorry, that's +1. +2, -1, -2, just scaling so that we can see the picture. Now this is a sine function. So sine starts first value at 0. Amplitude is 2, but it's a negative direction. So the next point would be at -2. Following your curve, you're going to head back up, keep going up, and head back down in your period length. So this is your graph. Follows the same pattern, stretched by 2 in the negative direction, and you have your 5 points. This will help us now look at our increasing and x-intercepts. X-intercepts are where it crosses the x-axis, so these 3 points. And then it's increasing in this interval right here. As you read left to right, it's increasing. So let's write those down. X-intercepts, remember, they are points. So 2 pi over 9, 0 is a point. 5 pi over 9, 0, and our last point of 8 pi over 9, 0. And the interval it's increasing is 7 pi over 18 to 13 pi over 18. So a lot of things happening here. We started with a normal sine function, stretched by 2 in the negative direction. This gave us a phase shift over 2 pi over 9, and it changed our period from 2 pi to now 5 pi over 9. Wowza. A lot happened in there. If you have questions, write them down. We'll talk about it in class. Let's do our last example, though, as one more problem for reference. So this problem is y equals 2 minus 3 cosine pi x minus 5 pi over 6. Let's write all the information down, and then we'll put it on the graph. So looking at it, right away, this 2 is kind of new. It's kind of out of place. We're like, what does that do? You may see it like this, or more commonly, it's going to be at the end. It's the same, doesn't matter. What it's telling us to do is take your whole graph and go up 2. Think about when we did our absolute values, our parabolas, everything added at the very end or subtracted tells you take the whole graph, move up or move down. This is telling us our amplitude is 3. And that negative sign just says instead of going the normal down direction, we're actually going to go up for the cosine. We also have this mamma jamma in the middle. Think about a normal cosine function has a period of 2 pi. So I'm going to sandwich that between 2 pi. I'm going to add 5 pi over 6 to both sides. Get your common denominator. Divide by pi. So kind of interesting. I actually get rid of pi. That's okay. That really is really fun. I'm going to start here. I'm going to end here. That means I'm shifting to the right 5 over 6. And my period will actually change as well. So let's get some information down. My amplitude is 3, based on right here what I wrote. My period, well, my period is now between 5 over 6 and 17 over 6. That difference is 2. I need to find my x-intercepts, which we will find from our graph, and where it is increasing. And that will also be found from our graph. Now that we have our starting and ending value and our amplitude, we can start graphing this. So let's go back to our graph. I'm going to draw my xy axes. I'm going to put it a little bit lower this time just because of that +2. This is going to come in handy in a moment. You want to have it a little bit lower just so we have enough room for our graph. I think I'll put every value by 1. It's not a bad idea. So 1, 2, 3, 4, 5, -1, -2, -3. Now, what I like to do in a situation like this, because the +2 here, I'm going to put maybe a dashed line here. This is my new x-axis. Everything from there with my cosine function will look like a normal cosine with my x-intercepts here. Okay, I'll explain what I mean by that. So first off, we have to divide up our x-axes. We start at 5 over 6 and end at 17 over 6. So maybe I'll go every 3. That seems good. So 1, 2, don't want to use that anymore. So 1, 2, 3, this will be my 5 over 6. 1, 2, 3, 1, 2, 3, 1, 2, 3. You need your 5, and you end at 17 over 6. We need to find our middle term, so you add them up, divide by 2, 11 over 6, add 5, 11, divide by 2, add 11 over 6, 17 over 6, divide by 2. And I'm just gonna, for this one, move them down just to stay organized. Just showing you some options. Now, it's a cosine function, so cosine normally starts 1 unit above your x-axis. But this is an amplitude of 3, and it's negative. So instead of starting here, it wants us to go by 3, but in the opposite direction. So that means here's my x-axis, 1, 2, 3. This will be my starting point. because this right here is that +2 of shifting the graph up 2. Since it's cosine, I'm going to follow my pattern, head to my new x-axis, keep going up, notice amplitude of 3, come back down from my third point, and I finish here. This is my curve for this problem. What's interesting to note is you also could have just graphed on the normal x-axis and then just grabbed every point and moved it up 2. If that's something you prefer, you're easier to look at, great, love it, and you're set to go. So let's figure out the rest of the information here. The x-intercepts. Well, interesting enough, these would be the x-intercepts, actually on the x-axis. Okay, we don't shift up and worry about those. We're actually caring about these x-intercepts. Well, they're not going to be on nice values. So we'll talk about that more when we get to that. But for now, I'm okay with us either typing this in and finding the intercepts, or we'll just write that they're not whole numbers, not exact, and we can just leave it. That's fine with me. Increasing, we have to notice, is just from here to here. So increasing our interval would be 5/6 to that max point of 11/6. Again, these two problems are really intense. So if you're a little confused, that's okay. We'll talk about questions in class, and then day 6 will be a nice, slower picture of these graphs. Good luck.